Hi everyone and welcome back to my channel. So today we'll be looking at an introduction to functions. So let's start by talking about what functions are really. So your functions are rules, that give you a value. So any rule that gives you an output where you have to put an input is a function. Kind of think of it like a machine where you put in something and then it produces something, you know. So let's say that whatever that machine produces becomes your output, and whatever you feed the machine is your input. So that illustration is same for a function. Another good example would be like when you use your calculator. If you input 2 plus 1, the calculator gives you 3. Now this plus sign or the addition is the rule, and the numbers, this would be your input, this two your input, and this your output. So a function is any rule that assigns a value to every input. So for every number you type on your calculator, that would be your input, and whatever your calculator displays on the screen would be your output. Now your input can be addition, it can be multiplication, it can be exponential, but for every other number or digits you type into your calculator would be called your input, and whatever your calculator displays as a result is your output. So I think that's clear enough. So functions can be expressed as equations. Functions can be expressed as a graph or as table of values. So we'll be looking at that one by one. So let's see that our first function, we call this f of x. It's used to write down a function, or it's used to say that whatever it is f of x is a function. It's pronounced f of x. It could be g of x, it could be h of x. All these are used to show that whatever it is we are talking about with this is a function, or whatever it is we equate this to be more precise, is a function. So if we say g of x equals x plus 2 all over x squared, this expression right here equating to g of x is a function. So for a function, let's use f of x. For a function, we said f of x is equals 3x. If x is 1, let's say f of 1, this means 3x would mean 3 times x. So where x is 1, that would be 3 times 1, and our output would be 3. So we call 1 our input, and we call 3 our output. So another fancy name for input would be our independent variable. We'll call this our independent variable. And another name for our output would be dependent variable. And our output is called dependent variable because the value of our output depends on the value of the input. Now this is 3 because our input is 1. If our input changes, let's say to 15, the value of the output changes. If we had f of 15, our value changes from 3 to 45. That's 3 times 15 equals 45. So this means that the value of our output really depends on the value of the input. That's why it's called dependent variable. Also, our output can also be called image or range, and an input can also be called an element of the domain, So I'll be talking about that in the next slide. So there's really a fancy name for all possible inputs of any function. Let's still use f of x equals 3x. For this function, you can have every number, every real number, every negative number to 0 to every positive number in this function will surely give us an output. So a fancy name for every possible number we can use as an input is domain. That's the fancy name. So for this function, where every possible number we can think about would surely give us a value, we say that the domain is from negative infinity to infinity. So for f of x equals 3x, if we had f of minus 1000, that will give us minus 3000. So for every input we can think about, there would be an output. So the domain would be from negative infinity to positive infinity. And its range is a fancy name for all possible outputs. So if all possible inputs would have all possible inputs in here, it also means that all possible outputs, the range, which can give us any number at all, would be from negative infinity to infinity. I just hope this is clear enough. Let's use some other function. So we can use, let's say, g of x equals x all over x plus 4. So when you have a function like this that has a denominator, right, you always remember somewhere in your mind that any number divided by 0 is undefined. So the first question you ask yourself is, for what value of x do I substitute in this denominator that could possibly make the denominator a 0? In our case, it's minus 4, and that's because minus x over minus 4 plus 4, this gives us equals 0. So it means that at x equals minus 4, this function is undefined. So if that's the case, it means that minus 4 will not be in the domain of this function. So there are many ways to write that. If you are asked to specify what the domain of this function could be, you could say x not equals minus 4. But you can also express the domain as intervals, and that's a better way to write that. So for this function, we can go from negative infinity to every other number except minus 4. So it means from negative infinity to minus 4.0111 should, be in this domain, and numbers just after minus 4, that's minus 3.999 to infinity, would be in this domain. So to express this as intervals instead, you go from negative infinity to minus 4 with a parenthesis, union from minus 4 to infinity. Now, let me briefly explain why we use parentheses. So when we talk about intervals, your parentheses here simply mean that minus 4 is not part of this interval. So the values in this interval will include every number every number just before minus 4. And the values in this interval will include every number just after minus 4. If we were to include minus 4 in this interval, instead of a parenthesis, we would have square brackets instead. This shows that minus 4 is part of this interval. Minus 4 is part of this interval. But if we have a parenthesis instead, that will show that minus 4 is not part of the interval. This works like, you remember that topic where you expressed inequalities on a graph? Let's just talk about that briefly. So if you say x greater than 5, and this is your number line, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so for x greater than 5, that would be an open circle at 5 and then an arrow pointing to the right. But when you say x greater than or equals 5, it becomes a closed circle. You shade the arrow. So it's just the same concept for expressing our domain as intervals, where we use parentheses. And so your parentheses, you think about your parentheses as the open circle, and you think about your square bracket as the closed circle. All right, so let's move on a little bit. So we can also express our functions as table of values. And when our function is, let's say our function is, we've been using 3x. So it means we have x, function of x. This would be 3, let's say, where x is 1, 2, 3, 4. So here you would have 3, 6, 9, 12. So in cases like this, even if you are not given the function, from this table of values, you can see that every input or every value of x is tripled. So you see that f of x is equals 3x. Also, our function can be expressed as graph. Our function can be expressed as graph. And let's just draw a little bit of a graph. So when our function is expressed as graph, you have your x on the x-axis, and you have your y, your function, your output on the y-axis. So let's just see how that goes here. So let's say this is our graph. Let me choose a thinner pen. Okay, let's say this is our graph, and it goes from, this is our y-axis, this is our x-axis, this is our x-axis, not y-axis, this is our x-axis, x, and this is our y-axis, this is our y-axis. So we'd call this point the origin. Let's say this is 1, 2, 3, 4, and this is -1, -2, and let's say this is 5, 10, 15, 20. So when x is 1, y or function of x is 5, and when x is 2, our y or function of x is 10, when x is 3, our y or function of x is is 15, and when it's 4, our y, a function of x, is 20. So when you join this point, let's join this point. This is supposed to pass through the origin. So when you join this point, yes, so this is the graph line, and you can also say this is the graph of, in this case, for every input we had, our output was 5 times the input. So it means that this is f of x equals 5x. So from this graph, you can answer questions like, if you were asked, let's erase this a bit. If you were asked, find f of 3. Find f of 3. So to find f of 3, what you do is, since your x is 3, on the x-axis, this is the y-axis, on the x-axis, locate 3, then trace out 3 upwards until it meets the graph line, and at whatever point it meets the graph line, find the y-coordinate. So the y-coordinate is at 15, so this means f of 3 is 15. And you can also answer questions like, find f of x when it is 20. So for questions like this, it's just like working backwards. So you find 20 on the y-axis, which is this, and you trace it out till it meets the graph line. Then you find out its corresponding x coordinates, which is 4. So x is equals 4. So I think this is a fairly good, a very good introduction to functions, and we'll be continuing on this series in upcoming videos, and I look forward to seeing you. If you liked this video, don't forget to click on the like button, share it, subscribe to my channel, and I'll see you on the next one.